Hello everyone. Thank you for coming today. My name is Hayao Suzuki. Today I will talk about let's implement useless Python objects. Before we start it, let me share some links. Just write and code on GitHub. My GitHub account. And if you want to share on social media, please use the hashtag PythonAsia 2026. So, let me introduce myself quickly. My name is Hayao Suzuki. You can find me on X, former Twitter, as follows. So I work as software engineer at Tokyo Gas. And so I playing tuba in the Tokyo Gas Wind Orchestra. So this is tuba mouthpiece. So okay. So about Tokyo Gas. So Tokyo Gas is the largest natural gas utility in Japan. So Tokyo Gas production and sales of city gas, LNG sales, and etc. So and gas pipeline service business, supply of city gas, and production and supply and sale of electricity. So first picture is my own instruments. So second picture is Tokyo Gas building. So I have given many talks on PyCon events. Actually, I gave a similar talk of PyCon APAC 2023. Today's version is updated for PythonAsia 2026. You can find all my best talks on my. You can find all my past talks on my blog. This URL. On slide and source code and so on. So, okay, that's enough about me. Let's get started. Today's theme is let's implement useless Python objects. Useless Python objects. So, the keyword is here useless. What does that mean? And why should we care? So, why useless? So let me explain. So, what does useless mean? I looked it up in the Longman Dictionary of Contemporary English. The first meaning is not useful or effective in any way. The second meaning is more informal, so unable or unwilling to do anything properly. Today, we will make Python objects that match these definitions. They look normal. They have the right method. They pass type checks, but they don't work properly. For example, imagine a container. So you put a spam inside a container. So inside the spam, you ask, is spam in the container? And the container says no. That's a useless object. So, by weight, so it's useless. It's really useless. So let me show you a quote. And this is Zhuangzi, an ancient Chinese philosopher. He lives about 2,300 years ago. So the quote says, everyone knows the uselessness of the useful, but no one knows the usefulness of the useless. When we try to make something useless, we must deeply understand how things work. We need to know the rules first. Then, we can break them in a funny way. So, making useless things is actually a very good way to learn. The useless teaches us about the useful. And this is the key message today in this talk. So, the useless objects are useless. But how to make a useless object is very useful. The process of making useless objects teaches us important things. We learn about object protocols. We learn about abstract base classes. We learn how Python works inside. The goal is not the useless object itself. The goal, today's the goal is learning through the process of making useless object. Remember this idea. Let's keep it in mind as we go through the examples. Okay, let me show you some example of useless objects. First is a layer container. You create with a list and spam, egg, bacon. Then you ask, is spam in the container? So spam in C. Container says false. Is tomato in the container? It says true. Tomato in C equal to true. It always right. Right. That's why it's called layer container. Next is a Fibonacci size. You create it with range 50. So this container has 50 items. But when you call the len function, it returned about 20 billion. It returned a Fibonacci number instead of real length. And next is shuffled iterable. You can create it 1, 2, 3, 4, 5 list. Every time you loop over with four statements, the order changes. First time, 5, 3, 4, 2, 1. Second time, 4, 1, 2, 3, 5. Third time, 2, 5, 3, 1, 4. So you never get the same order. So what is a useless Python object? Let me give a definition of the useless object. A useless Python object behaves Pythonic, but does not work as expected. This is important. The object follows Python rules. It has the right method. It's the right interface, but the behavior is wrong. To make such an object, we need to understand what Python really means. What is the correct interface? What method do you need? That's what we will explore in the rest of this talk. Let's start with Python basic data structure. Python has 4 main data structures: list, tuple, dictionary, and sets. You all use them every day. These data structures share common operations. For example, len function and in operator and for statement. So, have you ever wondered how does Python know what to do. How does len work on both a list and dictionary? Why? So the answer is an object protocol. Each operation uses a special method. So, for example, a len function calls dunder len method. In operator calls dunder contains method, and for statement called dunder iter method. They are called dunder special methods. If we define these methods, we can make our own objects you work with len function in operator and for statement. And if we change these methods, we can make useless objects. Let me show how you have. First, the in operator and the container class. Look at a layer container. It inherits from container class. The dunder contains method has just one line: return item not in self data. See the word not flips the result. If the item is in the data, it returns false. If the item is not in the container, data return true. One line of code makes it completely useless. Next, len function and the size classes. Dunder len method is called for the built-in len function. So Fibonacci size inherits from size. Instead of returning over the real length, it calculates a Fibonacci number. So if your data has 50 items, len returns the 50th Fibonacci number, that is 20 billion. And the for statement loop with the iterable classes, the dunder iter method is called when you use a for loop. Shuffle iterable inherits from iterable. Dunder iter is used random sample to shuffle all items. It returns a new random order every time. So now we have time-based useless objects. Each one breaks one operations. To make useless objects, we first need to understand object protocols. Object protocols are the rules for how Python objects should behave. You can read the full details in the Python data model differences. The URL is on the slide. And Python gives us a very useful tool, the collection.abc module. This collection.abc module provides abstract-based classes. They define the interface of different types of collections. We already used container size iterable classes. These all come from collection.abc. Here is the summary table. Size abstract class needs dunder len method. Container abstract class needs dunder contains method. Iterable abstract class needs dunder iter. And collection classes combine size, container, and iterable. If your class inherits from collections, it must have dunder len, dunder contains, and dunder iter. Then Python knows your class is a collection. So we can combine our uses classes. Look at the uses collection. It inherits from Fibonacci size, layer container, and shuffle iterable. The class body is just pass only. We don't need any new code. Python multiple inheritance does the work, and these uses classes become one super useless collection. This is the power of the abstract-based classes. let's go further. Collection.abc also defines ABCs for Between types. Sequence is matches tuple. Mutable sequence is matches lists. Mutable set matches set. Mutable mappings matches dict. Let's implement some more uses objects using these classes. First, this is a modular sequences. Modular sequences inherit from sequence. The key method is lambda get item. This is called when you square brackets like sequence and bra5 get. Look at this code. It uses Python's match case syntax to handle different key types. When the key variable is an integer, it uses modular arithmetic key modulo len of self data. So the index wraps around. If the data has 20 items, index 0 and index 12 gave the same result. Index 21 is the same as index 1. The same logic applies to slices. Let me show you what happens. Create a modular sequence with range 20. It has items to 0 to 19. Sequence 21:44 returns 1 to 3 list. The indices wrap around. Sequences 65,543 returns 3 because this number module 20 is 3. Here's the fun bug. If you can sequence count 30, it never stops. Because sequence provides count for free, but count checks every index from 1, 0, 1, 2, and so on. And our sequence has no end. Every index wraps around and gives a valid result. So it wraps forever. This is a great example of an unexpected side effect. Modular sequence, it only defined lambda get item method. So Python used lambda get item as a feedback for iteration, calling index 1, 0, 1, 2, and so on. That the while count and run forever. Now, look the computation sequences. It defines both methods, lambda get item and lambda iter. So, lambda get item returns items in normal order, but lambda iter returns then a reverse order. When both exist methods, which one does the for loop use? I think normal order. Reverse order. I don't know what you say. Okay. Okay, yeah. Next. So let's see. So if S0 gives a L, that's a lambda item. But list S gives G, F, E, D, C, B, A. Reverse, because list iterate and iteration use lambda iter, not lambda get item. So modular sequence has no lambda iter, and Python fall back to the lambda item. Computation sequences has both, and Python chooses lambda iter. When lambda iter method is defined, it always wins. Next is misprinted dictionary. It inherits from mapping classes. In lambda iter, it takes a normal dictionary, then it rotates the value of by one position, shifting each value to the next key. So The key are the same, but the value has moved one position forward, like a misprinted book where the pages are in the wrong order. Look at this example. You create it with A1, B to C, and C to 3. Accessing the values, A of D is 2, B of D is 3, and C of D is 1. Every value has shifted to the next key. But this D key returns ABC. The keys look perfectly normal, and Ray and D return 2. This class inherits Fibonacci sizes. So the keys are correct, but the values and the lengths are both wrong. The last example is cross set. Inherits from set. It also uses function total ordering. This class has used a trick than the less than method. Instead of checking self data less than or equal to other data, it checks self data greater than or equal to other data. So the comparison is reversed. And the set of operations are swapped than the and than the or. So everything is reversed. It close set. Here's an example. S equal to egg, bacon, spam set. T is a cross set, egg, spam, egg, spam, spam. So if S larger than T, so true. And S and T returns bacon, egg, spam. So this set is a union set, but and S or T returns X span. This results union classes, intersection classes, intersection sets. Sorry. Let me wrap up. So today, these things to remember. So first, useless Python objects are useful. The process of making them teach us about Python. Second, the collection ABC model is very useful. It gives us abstract base classes for all kinds of collections. Third, once you understand object protocols, you can do anything. You can make normal objects. You can make useless objects. You understand how Python really works. So I hope this talk inspires you to try making your own useless objects. It is a fun way to learn Python deeply. Thank you for very much.